So hello everyone, this is Dr. Syed Altaf Hussain. So Professor of Mechanical Engineering, working at Rajiv Gandhi Memorial College of Engineering and Technology, Nandyal, Andhra Pradesh. So I have been working in this institution from the past 18 years. So earlier I worked in different states, particularly in Tamil Nadu. In total, I have 25 years of teaching experience. Today, I am going to demonstrate how to prepare a sample for a microscopic examination at our material science laboratory. Material science. So material science, it is an interdisciplinary field which deals with the study of properties of the material based on its microstructure as well as its chemical composition. So materials we are using for wide variety of applications ranging from automobile, aeronauticals, energy, healthcare, even for domestic applications also we are using varieties of materials. So appropriate selection of the material purely it depends upon the service condition. Based on the service conditions, we have to choose the appropriate material. For preparing a SAC examination, there are certain specific stages are involved. In that, first stage is specimen selection, and the second stage is cutting, and third stage is mounting the specimen, and fourth stage is grinding, fifth stage is polishing, and the sixth stage is then etching, and seventh stage is rinsing, and final stage is microscopic examination using a metallurgical microscope. In the first stage, specimen selection. In the specimen selection, we have to take a material of interest from the appropriate region. So, which region supposed to be studied, whether it is a fractured region or a material. So, from that huge stock, we have to cut a sample with the help of appropriate cutting tools. Then afterwards, the sample size is very small. The sample is having similar properties as that of its base material. It is very small in size. You could not be able to handle it and handle with the help of our hands. That's why we have to accommodate this sample an appropriate medium. With the help of some devices, we have to make use of a specimen mounting press. In that specimen mounting press, on that platform, we have to place our sample, and also we have to fill that cavity with the help of thermosetting resin. Then afterwards, we have to compact the powder, and also we have to rise the temperature. At high temperature, that thermosetting resin melts and solidifies, and it will hold the sample. So that the sample was ejected from that mounting press. Then afterwards, is supposed to be passed on through various grinding stages, grinding papers or emery papers of different increasing grid sizes. The purpose of this grinding is to flatten the surface and also to remove the irregularities present on the surface of the specimen. Once this grinding operation is completed, we have to go for polishing. The polishing will be done with the help of a double disc polishing machine using a diamond paste and this alumina oxide powder. And then after polishing, we will get a specimen surface of mirror-like finish. Now the specimen is ready for microscopic examination. Before taking the specimen for microscopic examination, we have to go for etching. It means we have to treat that surface of the specimen with some chemicals. So we have to use appropriate etching agents that depends upon the material to be examined. So here we have to use a picrol, nitol, nitric acid. So we have to use the different types of etching agents. When you apply this etching agent on the surface of the material, this etching agent reacts with the phases present on the material, and it will give some contrast, so that when you observe this microstructure, we can clearly distinguish different phases present in that material. Afterwards, after etching is over, we have to clean the sample under a stream of water as well as with the help of compressed air. we have to write the surface, then we have to take the surface over to this microscope, metallurgical microscope. We have to mount the specimen on a microscope with the help of some adhesive medium. Then afterwards we have to focus that sample with appropriate lighting and magnification. Then afterwards we have to see this microstructure and identify the faces. By seeing the faces present in that material, we can assess the properties of that particular material. Even though we can assess the chemical composition of that material, right? Based on the microstructure and the chemical composition present in the material, we can assess that property of the material. So most of our ferrous, even non-ferrous materials, whatever the materials we use in our engineering, all the materials are polycrystalline materials. When you see this microstructure, you can see so many crystals in it. Even based on the size of the crystal also, we can assess the properties. If the material is consists of fine grains, if it is a fine grain structure, we can say that material possesses very good mechanical properties. If that material possesses coarse grain structure, we can say that material is having poor mechanical properties. Okay, let us move to the laboratory and I will show you how to prepare the sample for microscopic examination. So this is called a specimen cutting machine. So that huge material is placed in this machine and a small sample is cut out from that huge material. So this is sample collection. This is a sample collection from huge stock. So this sample consists of similar properties as that of its base material. So it is a specimen molding press. It consists of a pneumatic jack which was raised and lowered by this lever, and here we have a cavity. In this cavity we have to fill that thermosetting resin to the designed mark. Then afterwards we have to compact that powder, and then entire setup was raised to a temperature of 300 degrees centigrade, and we have to maintain the temperature for 10 minutes. At this high temperature, in that duration, that entire thermosetting resin was melted and it was solidified. Once it was solidified, the specimen is taken out of this press and it is look like this. It is look like this. Now our specimen is embedded within the background material. Now the background material is a thermosetting resin, it is a backlight. So here we have one belt polisher. So here we have a belt of different grit sizes. So with this machine we can polish, or not a polish, what we can say is we can remove the scratches and irregularities present on this specimen by doing this polishing operation, so on this apparatus. So another stage is after removing these irregularities and scratches present on this specimen with the help of this belt polisher. Next subsequent operation is we have to rub this specimen and different grit sizes of emery papers. Here you can see stands. You can find emery papers of different grit sizes of progressive nature, and on each emery paper we have to rub the specimen in opposite strokes so that we can make that surface to be polished. So like this we have to do this polishing on these emery papers. When we are going for the next emery paper, you have to reverse the stroke to 90 degrees. Again we have to go for opposite stroke. Like this we have to perform this rubbing operation on emery papers of different grit sizes so that we can produce a smoother surface on the specimen. After performing this polishing operation on emery papers of different grit sizes, our next stage is to have a specimen of mirror-like finish. This could be obtained with the help of this double disc polisher machine. So here we have a rotating disc. Over this rotating disc we have to sprinkle alumina oxide powder, and then we have to press hard our specimen on this rotating disc. Then afterwards we have to apply the diamond paste over the specimen surface. Again we have to perform this operation on the other disc. So we have to do it for some period, then afterwards we will able to produce a surface of mirror-like finish. So after polishing operation, the next stage is etching. On this polished surface, we have to apply this chemical agent. So it is a very important stage in this process of finding the microstructure of a material. So we have to choose appropriate etching agent that depends upon the material to be examined. So here I have a nitol. It consists of 2% nitric acid. So this nitol is supposed to be applied on ferrous materials like carbon steels and cast irons. So once you apply this nitol on the surface of a polished specimen, this chemical agent react with the phases present in the microstructure, and it will give the contrast, a different color compared to its neighboring crystal or neighboring phase, so that we can easily differentiate different phases present within that microstructure. Once the etching operation is completed, we have to rinse the sample under a stream of water, and we have to dry it with the help of compressed air, and that dried specimen is supposed to be placed on this metallurgical microscope. If possible, we have to use adhesive agent for mounting the specimen. Once the specimen is firmly mounted and there is a slide of a microscope, we have to adjust the lighting as well as the magnification for our microscopic examination. We have to focus that sample, that polished region, and we can observe this microstructure over a screen. So in this screen we can find phases present in the material. So we can see the effect of etchant on the microstructure. So because of the etching, we can clearly distinguish different phases present in the material. So here we can see some black region and some white region, as well as we can estimate the grain size present in that microstructure. See, in this entire video, I was demonstrated how to prepare a sample for microscopic examination and what are the stages actually involved in preparing a sample for microscopic examination. I think this video is a quite informative one for you. So thank you very much.